There's a lot of questions in the chat box. All right, Les has the first one, and it's what about infiltration rates?
Yeah, so we did not look at infiltration as part of this study, but I can say, again, this is a drainage research site, so we do have the drainage data. And if we look at that over a long period of time, we do see greater infiltration in our no-till plots. It's a little hard to pick out of the data because there's a lot of plot to plot variability and a lot of year-to-year variability. But if you average it over a long term, we do see a little bit better infiltration in no-till, which is what you would expect. And again, that's kind of my point with the bulk density thing. I hate to put too much emphasis on that because a higher bulk density in no-till doesn't necessarily mean that your soil health isn't as good.
And then Don asked, what about active carbon or protein levels?
Yeah, again, great questions. And these are all things that you certainly could look at. We didn't do that as part of this study. You know, there's only so many hours in the day and so much budget. So there's certainly other soil health indicators that'd be great to look at. And again, that's why I don't want to put too much emphasis on our results and say that, you know, continuous corn systems have better soil health, because we didn't really look at a lot of those biological indicators that are available to be measured.
Okay, Victor asked about soil organic matter, and I think that came in right after your first study and not the second. I think you answered that one. Don asked, could you have run Solvita tests?
Yes, we discussed that sort of at length, and that was my initial plan, was to do Solvita. But when we look back at, you know, some other research studies and where they had tried to do the Solvita test, at least the rapid test, there's just a lot of variability that can change from week to week. We're trying to look at a little bit more kind of long-term indicators here. You know, if you get a rainfall, for example, and you measure before versus after, and you'll get completely different results on that Solvita test. So we did consider doing that, but ultimately opted not to look at carbon respiration. But I do think if you do that in the lab, where you dry that soil so it's all consistent and you re-wet it, that can be a good soil health indicator.
Okay. Don asked a good one here. Did you look at earthworm activity of deeper roots by providing those pathways for that carbon to go deeper?
No, we didn't, and that's a great question. So that's something I've been puzzling over, is how is that carbon, you know, getting deeper in the profile? It could be, you know, corn and soybean roots can easily go down 1 meter or more. So it could be just degradation of dead roots. It could be, you know, root exudation that's putting some of that carbon down there. Or, you know, again, it could be some of that carbon actually dissolving at the surface and then re-precipitating out deeper in the profile. So certainly some different pathways for that carbon to get there. I don't have a good explanation, or, you know, we haven't really looked into it more closely to determine exactly how this is happening.
Okay, thank you. Charles kind of has a comment. Increased corn yields over time would contribute larger C now compared to 30 years ago.
Yeah, that's a good comment, and something I didn't mention in the presentation, but in our cover crop treatment in particular, that was a spring UAN side dress for 8 out of those 10 years. And we did tend to have some yield challenges with that system. So the cover crop treatment consistently had a lower corn yield. And so there was probably less residue input from the corn side of it there. So that could potentially have offset, you know, some of your benefits of having a cover crop. So yield is certainly important, and the amount of above ground residue that you're putting back into that system is certainly important.
I think you just touched on this, but Dan has a question. Type in growth of cover crops and the difference.
Yeah, so at this location, we just had cereal rye. You know, that's the only thing that really consistently will overwinter in kind of north central Iowa there at this location. You know, you can certainly look at other species, look at cover crop mixes, and starting next year, we actually, or this spring now, we actually will be implementing some early interseed multi-species cover crops on these same plots. in both 30 and 60-inch row corn. So, and we're also going to have a perennial bluegrass treatment on these plots as well. So some pretty exciting stuff coming up, and really looking forward to seeing what those, multi-species cover crops and perennial cover will do to, not only the water quality, but some of these soil measures as well.
Okay, one more, and then we'll split into our discussion rooms. And this is an interesting one. I guess I want to see how you're going to answer this. If soil health won't sequester carbon, then why all the seed trading systems popping up?
That's a great question. I'll get myself in trouble on this one now, but no, great question. There's huge interest, in the industry and from government and from private sector, pushing carbon sequestration. Again, I think it's fantastic, but I just want us to be a little careful, and we don't want to just assume that all of these different soil health practices are going to put carbon into the soil and keep it there. There's a lot going on there. A lot of the interest, I think, is being driven by private sector. You've got companies that are wanting to reduce their carbon footprint, but maybe they can't do it for whatever reason, so they'll just buy those carbon credits and basically pay farmers to do it for them. I mean, that's great, but I worry that once these companies actually start measuring down, a meter deeper and tracking that over time, might be a little disappointed in how long it takes to, change that system. You got those legacy effects and a lot of other things affecting it there. So that's certainly something to consider. If I could wave my magic wand, I would say we'd be better off to just assume that on the aggregate, these soil health practices are good for society. They're good for the environment. We know that they can help with water quality. We should just pay farmers to do these practices rather than trying to pay them to sequester carbon, which is sort of a potential offshoot of these practices. Just pay them to do it directly and assume that on the aggregate, it's going to be a good thing, instead of trying to measure, carbon on an individual farm in an individual year and then pay the farmer for that, because that can get very difficult to do. So I don't know if that answers the question, but it's a very complex and interesting topic.
Well, thanks, Brian. That was a very thoughtful answer. And I think that's a question that a lot of people are asking and thinking about now. So